Hello, I'm Steve Dietz, Field CTO at Sumo Logic. In today's Sumo Logic Illuminate session, I'll be covering observability and security from a common platform. A little bit about me. I've been really focused on security operations for the past 20 years, and I am really dedicated to SIM. Pretty much been doing that my whole career. So as you can imagine, things have changed a lot from being an Air Force intrusion detection analyst where I was guarding 12 air mobility command bases, being a analyst, all on-prem, massive infrastructure, to now being at Sumo Logic Field CTO, where everybody's moving to these cloud native modern apps. So once again, welcome to the session. In today's session, we are going to be covering serverless functions, specifically a little bit more with a focus on Lambda. And we'll talk a little bit about the first cryptocurrency miner that was discovered earlier this year that was specifically targeting Lambda. Then we'll switch to how today our observability platform is already monitoring Lambda. And then in addition to that, we'll talk about how this data from observability can be used for security monitoring. So a little bit about serverless functions. Here we can see that the functions continue to grow as more modern apps are developed. And even those modern apps that have already been developed, customers are switching to more and more cloud functions. And here we can see the growth from Lambda, Google Cloud, and Azure. And then in addition to that, from our own Sumo Logic Continuous Intelligence report, we see that 2 and 3 enterprises are adopting serverless Lambda functions. And we can see that the growth has increased dramatically from 24% to 39%. So the growth continues from a Lambda standpoint. And then here's just a nice chart that shows that growth amongst our Sumo customers. So we see the growth and it will continue to grow as Lambda becomes more and more popular as customers look to reduce their footprint inside their cloud environments. Some questions to be thinking about as I walk through this today. What does your security team know about the different microservices related to the cloud native app? Does your SRE, observability, and CloudSec team know if there are any threats related to the apps, their underlying services, or to the broader cloud environment? What is your security team doing to get good visibility into modern apps? So in January 2022, the first crypto mining targeting Lambda was released. This was actually discovered by Cato Security. And this is a nice quote from Matt Muir of Cato Security. Although the first sample is fairly basic in that it only runs crypto mining software, it demonstrates how attackers are advanced cloud specific knowledge to exploit complex cloud infrastructure and is indicative of potential future more nefarious attacks. A little bit about Denonia, which was the first malware targeting Lambda. Like, like I said, first sample on VirusTotal in January 2022. The sample was analyzed first by Cato in February 2022. They believe is most likely deployed through compromised AWS creds. It was written in the Go language, but actually called Python. And there we can see some libraries that were tied to the malware. The most concerning of those is the Go, which is DNS over HTTPS. So this made it easy to evade a lot of default detection mechanisms inside AWS because they're able to hide their DNS over HTTPS. It then deploys XMRig, and then it starts up XMRig from memory and communicates with the attacker-controlled mining pool at the address and over port 3333. So that was a little bit about that first malware targeting Lambda. And then next, we're going to talk a little bit about the observability. So this quote from a Twitter feed was a user's creds were compromised. He didn't know how, but he actually was charged $45,000 of server time, so the scammer itself could make $800. So attackers, threat actors are going to be opportunistic here, right? As cloud infrastructure is growing, what are the chances that a organization or individual actually knows that their keys have been compromised and that they're now fitting it? They have a bill for an extra 45K, right? So we'll kind of go over that, why that's important from an observability standpoint, and then move on to some security use cases. For those not familiar with observability, there's really three pillars: logs, metrics, and traces. And individually, these external outputs provides a useful way to monitor a system, but really it's bringing them all together, analyzed and interrogated in real time. These outputs make systems observable. So first off, let's talk a little bit about collection and how we're doing this from the observability side. So today, one of the ways to collect CloudWatch log is through, or Lambda logs is through CloudWatch. So here we can see the log at the bottom, and then we can see some of those details of duration, build duration, memory size, max memory used. And then on the right-hand side, just a little bit of a diagram on how those logs are actually collected. Next, we can see that another way to collect CloudTrail a little bit differently is through CloudTrail. And both of these logs, the CloudWatch and CloudTrail logs, are equally as important. Here we can see when and by whom an invoke API call was made. And then once again, you can see the sample log on the right, and then in addition, how we collect those logs through CloudTrail. And then lastly here is we do have another mechanism called our open source AWS Lambda extension, which will actually run as a lightweight process that runs within the same execution environment as your Lambda functions. And then it uses the Lambda logs API to send platform function and extension logs to Sumo Logic. So this is very similar to the CloudWatch logs. If you're going to go this route, we recommend disabling the CloudWatch and just utilizing this from a collection standpoint. But either way, you have to have at least your CloudTrail number one, and then number two, either this AWS Lambda extension or those CloudWatch logs. And then to finish up here, before moving into the demo, short runtime durations, the sheer volume of executions, and the dynamic nature of Lambda functions can make it difficult to detect, investigate, and respond to potential compromise. Under the AWS shared responsibility model, AWS secures the underlying Lambda execution environment, but it's up to the customer to secure the functions themselves. Let me just repeat that one more time. It's up to the customers to secure the functions themselves. Moving into the demo, we will see on the left-hand side our AWS observability solution. Here we can see all of our AWS accounts on the left-hand side. And what's nice about this, if I click on the different account, it will then break down all the activity from that account. And here on the right-hand side, we can see application load balancers, API gateways, Lambda functions, Elastic Cache, DynamoDB. Every resource inside your AWS environment in service is being monitored. And then we can drill down further here, where we can drill down into USD1, and it will list all the services out once again. So from an analyst standpoint, I now know what I'm actually protecting inside my AWS environment. This can be a little bit challenging at times, but here, if I'm an analyst and I have visibility in this dashboard, I can now see what I need to actually monitor and protect inside AWS. In addition to that, from an observability standpoint, I now can see how these different resources are performing. But that's not all. Next, we can actually drill down into a the Lambda, which is the basis of this topic today. When I drill down into Lambda, it will load this dashboard where here I can get a high level overview of all my Lambda functions. In addition to that, we can see all the details from errors, throttling, duration, all very important pieces when it comes to observability and monitoring. Next, we can take a step down and drill into each one of these functions. All these functions are auto-discovered, and what that means is I don't have to go in and actually go find and add this to a panel, right? All these are auto-discovered, which also lets me know as an analyst and once again as an observability SRE is I know what is actually running from a Lambda function inside my environment. And here I can drill down into this function. And here is where I can see trend of cold starts, function duration, and cold start duration. And why this is important is from an SRE standpoint, is cold starts occur when the cloud provider scales up your functions behind the scenes to handle more requests. So your customers could see requests taking longer to complete when your functions need to cold start. So really nice to be able to drill down into these different Lambda functions. But it's also nice to be able to see how these relate to a modern app. So when we switch to our application service view, we now have the list of apps that are running inside my, in this case, AWS environment. On the right-hand side, what I really like here is the application architecture. When you click on this, I'm going to drill down in the coffee bar app. Here, I can see all my services as they relate to the application. Think of this from a traditional network security standpoint as, and you can obviously make this a lot bigger, but think of this as a traditional network security diagram. The first thing I did as an analyst was when I sat down in an environment was, can I see your network diagrams? Well, here how we can see how data is flowing through the apps and all the underlying services that make up this app. And of course, if there's any performance concerns in any one of those, but here we can see the Lambda functions actually sit outside the flow. But once again, this can be leveraged if I'm an analyst. I now have the ability to know what services relate to this application, and in addition, how the data is flowing through it. Next, on the left-hand side, I'm going to drill down into this Lambda check suites function, and this will provide us a little bit further of a deep dive on the actual function itself. And here we see the latency as it's going through this part of the application. And in addition, we talked a little bit about traces. This is where you can actually see traces as it relates to this check suite function. If you're not familiar with traces, it's end-to-end. If end-to-end latency starts increasing, you can see in an instant whether the bottleneck is due to code level issues of one of the Lambda functions, like hitting the limits for concurrency, or issues in service dependency. Next, we're going to switch over to our Lambda resource usage dashboard. The Lambda resource usage dashboard helps with things like duration and build duration for a particular function. In addition, it will show you memory usage as compared to memory allocated to the Lambda function. For those not that familiar with Lambda, you pay for allocated resources rather than actual usage. These memory stats can help identify over provision functions, so kind of help you balance that Lambda performance with cost. In addition, you can identify Lambda functions that are under provision and assign more memory to those functions to improve their performance. Once again, pretty nice to be able to look at this. There's one other thing that we see here too that's more applicable from a security standpoint is memory usage from an outlier perspective. So if somebody did compromise a Lambda function and updated it, having a memory usage outlier, which is basically an alert if memory goes 3 times out of the standard deviation, analysts would be able to recognize it's more of a weak signal that something odd is occurring with that actual Lambda function. In addition, they can use other signals like new Lambda function created for the first time and tie those two together to actually make more of a cohesive story. And you also have the ability to drill down into the function here with them also being auto-populated. So once again, if I want to drill down on a particular function, I can easily do so. Switching over to our AWS Lambda security overview dashboard, this is where SRE teams, observability teams, along with your security operations have one dashboard that they can both look at from a security standpoint. On the left-hand side, we see functions accessed from highly malicious threat IPs. So if somebody's making an API call, they're updating a function or running a function, we compare all those logs, which come from CloudTrail, like I explained earlier, to our built-in CrowdStrike threat intelligence. So this will let us know if there's ever a malicious IP that we know is bad calling a function. On the right-hand side, we can see Lambda signal count 7, number of Lambda insights. If you're not familiar with our insights cluster together related signals as they relate to an entity. And the signals you can think of as just alerts that we've seen coming from AWS or AWS Lambda functions. At this time, what I'm going to do is click the link to the insight. So as a SRE observability team, I can actually investigate this. And as a sec operations analyst, I can also investigate this. So let me go ahead and click that link. Here we can see the link takes me right into this insight. And here we can see the insight. We can see that we have a global confidence score of 10, which means we're not too confident. We don't see a lot of this type of activity. So we're not too confident, we feel, from a Sumo Logic perspective in our algorithm that runs on the back end, that we actually think that this is malicious. So as an analyst, I can see that there was a threat intel match and from a console login. This is a common indicator that creds have been compromised. Next, we see there is an AWS unauthorized change being performed to the update function. And then in addition, we see that this account was observed modifying a Lambda function for the first time. At this point in time, if I'm an analyst, I have severe concerns that this account might be compromised. My next step would be to actually run a playbook to disable the user's keys. To do that, I would hit create incident, and then I would choose my incident template or the runbook that I want to run. and I would select AWS account compromise, and I would hit create incident, and it would run that playbook in the background. When that playbook's done running, it'll actually post the results back to our enrichment. So here I can see that AWS remove key access keys was successful. So now as an analyst, I now know that this has been this user's keys has been removed and they no longer have access to be able to access that AWS environment. You're probably wondering, well, what exactly does that look like in the background? So in order to show that, all I would have to do is click on the related incident, and that takes me right to the incident inside Cloud SOAR. Here, inside the Cloud SOAR, we can see the playbook ran successfully. We can see when this playbook runs, it gathers the information from the insight. It does it lists access keys. It deletes the access keys. It then posts the containment back to Cloud SIEM Enterprise, and then it ends. So everything ran successfully, and that's why we saw it post the success back to Cloud SIEM. And then in addition, if I wanted to here, since this was a incident, I can add any notes that I wanted to. I can access the war room where it can be stuff can be shared across analysts. If there is an ongoing incident, everybody can be in that war room as it relates to this incident. And then I have an overall overview of the incident also. And as I work through this incident, once I go to close or I need to add investigators, I have those. But at this time, I would just close the incident. And now that will actually update the incident also in Cloud SIEM Enterprise, and it's now been closed out on that side from an insight. And that shows you end to end how we can go from observability data, transform it into security data, and have a cohesive platform to where both DevOps and security operations are leveraging our observability and security platform together, and how we're really trying and our customers are starting to shift left and seeing how observability and security are becoming tighter and tighter. So I want to say thank you for joining this session. Please enjoy the rest of the sessions. Look forward to seeing you next time in person.